Morning, student. Here I found 39 students are present, but I get a response from 2 only. Good morning, student. এখনো তোদের ঘুম ভাঙিনি বোঝা যাচ্ছে। Okay, I just wait for 1-2 minutes. So if someone is joined. Okay, let's start. I just recap the last class, whatever we discussed. So in the last class, we have started with the concept of digital signal processing. So where we are actually discuss the understanding between the three terms. So normally we are using DSP subject. We learn the DSP subject. We not say sometimes that a digital signal processing subject we learn. So that's the reason we discussed in the last class the understanding between the DS and P, then signal with analog, discrete time, and digital signal, whatever we actually work in this subject. And then so you already know the answer that why digital is paper. So basis on that, in the signal, if we consider the definition we discussed in the last class, that is signal is a variation of the physical parameters. So what are the physical parameters? Take an example over there. So we are considering three physical parameters. One is the temperature variation. Another is speech, as I speak. So voice, you can say the voice variation. Another is the video as the variation of the light intensity. And then we are actually present in the electronics domain, electronics engineering domain. So that's why we more specified the definition basis on the electronics engineering domain. So we just modify the definition where we just claim that signal is a variation of electrical quantity as a voltage or current in a function of time. And we also consider some example like motion, sound, image, video. There are so many examples are present if we consider the electronics engineering domain signal. Then we are seeing that the basic of the signal. So here we are considering a graph. Here we are considering a graph. That graph we found that this is the value is basically varying continuously in different instant. Whether in the x-axis we are considering as a time axis or t, and the y-axis we are considering as a voltage, as a amplitude. Then in the signal they having some range present, that is either 0 or v mean, or we are considering v max or maximum of the amplitude. So then we are discussing about the analog signal. So that such of signal we actually call the analog signal. So variation of the signal which can take any instant of time. It can take any value between those two limits like v mean and v max. and such a type of signal we call this is the analog signal. And this is some note I given in the last class we discussed. And the interesting part, the next signal, whatever we are discussed, that part will be little bit change. In term of t, we are considering n. So v is the function of n. What about this n? N is basically the time index we called. So here the process, the signal only at the discrete time of signal, discrete time. So like temperature monitoring process, if we consider, we can monitor the temperature every minute instant of time, or maybe every hours, or maybe every day. So the value of the signal Vn and instant of time, which is called basically time index. So this n is basically is the time index. In the DSP lab, you already practice some basic signal generation. And we are considering as a time index as n0, n1, n2, n3 up to nn, as long we actually want, because this is man-made signal. This is man-made signal. So that type of signal we call the discrete time signal. So now we found the another type of signal, that is a digital signal. So what about the difference between? So most of the time we actually forget about the or we sometimes little bit confused about the two signal, that is discrete time signal and digital time signal. Digital signal, basically what are the changes over the digital and the discrete time? In this case, in the both axes are discretized. Means either if we consider voltage or current in term of the electronics domain, the amplitude part is y-axis is discretized, and also the time axis, the variation of the signal, that is also depend on the time, which is basically here we found as the time index, that also discretized. So we are discretizing both time and amplitude part, and new type of signal we found, that type of signal we call digital signal. Now, most of you are familiar with the digital signal. So here I just show you some picture. So in the above picture, this is basically the analog signal, and this is basically the signal of digital, where we are considering as in bit format, like a 1 or 0. And the interesting part of this slide, that is this analog signal is a natural signal, and the digital signal is the man-made signal. So remember that. So whatever you want, you can change in the digital signal. You can modify it. That is the advantage of the digital signal also. So I already mentioned here also that we can use as we want. And now we are focusing on the advantage of the digital signal. This is basically, so you learn the microprocessor subject. And that time we also discussed, when we are discussing the basic of the microprocessor, basic structure of the microprocessor. That time I discussed with you why we are not prefer the analog, we prefer digital. So because of here we consider the 5-point measure. So lot of points are there, but I am considering major 5 point. It's yes, yeah, yes. Yes. Someone is interrupt me, please tell me. Should I continue? Anyone please response. I'm audible, no? Okay, so why digital? So I am here considering the most popular reason. So one is the sophisticated. The digital circuit is or digital system is more sophisticated. The size of the system is small. So I already mentioned this part is making by us. That means the man-made. So whenever the circuit or something is man-made, the whatever we want that depend on us, and depend on that we can change the circuitry. So that is the reason we can say also this is more flexible, low cost, and obviously low power. So a lot of example is there. Your mobile phone also, whatever you are using, that mobile phone power is very less compared to the, if we consider the analog mobile, if we consider, and if we add the features, whatever you found in digital domain, that time we require more power. So in the case of the digital circuit, it's require low power. So now we are considering the processing. So probably in the last class we discussed up to the last slide, no? Anyone response? Yeah, so I'm not discuss about this slide, no? Yeah. Okay. So DSP, the name are associated with another part, that is processing. I told you guys in the last semester, you are familiar with the microprocessor, you are familiar with the 8085, 8086, 8051 also. And you are also familiar with some other type of processor like ARM processor. That's fine. Now, this is another type of processor which we are discuss over here. That processor is related with digital signal processing. So doing digital signal processing, we are using that kind of processor. This is one kind, this is not a general purpose processor. So whatever we learn in the last semester, that is general purpose processor. That is general purpose processor. So we are doing in general purpose like 808586 ARM processor, but this is the specific processor or special type of processor here we consider, which is basically associated with the digital signal processing related. So now we are coming to this slide. So here you found that, so one speaker we are considering, one speaker is here considering, and one microphone which is basically recorded your voice we are considering. And naturally, you know, this part is analog. This part is analog, but your DSP processor is again digital. So that's why what we are considering, this is the basic circuit. I am not discussing a lot about the internal circuit. Whenever we discuss the DSP processor, that time we discuss that in detail. So we just consider here whatever we know, that is we are considering A to D converter, which is basically convert analog signal to digital, and then the signal goes to DSP processor, and that DSP processor associate with some memory, And what about this memory? The memory basically they store this data. As well as if we want, we just listen this song also, or play back the song, or whatever we are considering. So that's why DSP processor, after getting the input, they will move to D to A converter, and that D to A converter will actually send data to the speaker in analog form. I already mentioned, because this part is associated with the analog. So this is the basic thing of the processor. Whatever we want, we work with this. So now we are discussing about the syllabus, whatever we covered here. So you already know, you already attend some DSP classes, which basically taken by Molloy sir and Otonu Panda sir. So I am taken the specifically this part, which is associated with discrete Fourier transform. The shortage term we call this is a DFT. So here we discuss concept and relation of discrete Fourier transform and inverse discrete Fourier transform. We also discuss the twiddle factor new term. This is the new thing. Hopefully you are not learned this part in your signal system syllabus. We also deal with twiddle factor and their properties. This is very interesting. Then computational burden on direct DFT. Then we discuss the DFT IDFT solution using linear transformation. We can say linear transformation matrix. We can also here written that DFT IDFT matrix, because there is a computational burden are present. So that's why we are transform to linear, using transform to linear transformation matrix. Then we discuss the computation of DFT IDFT by matrix method. Multiplication of DFT also discussed. So you are familiar with one term, that is linear convolution. Are you familiar with linear convolution, guys? Guys, anyone please respond. Are you familiar with linear convolution? Are you familiar with this term? So it's like I just give some examples. Suppose xn is 1, 2, 1, 2. Hn is 1, 1, 2, 2. And using this method, you remember 1, 2, 1, 2, 1, 1, 2, 2. Add multiplication method, we can solve the problem. You remember, guys? Please response. Yes or no? Not understood. Please repeat. Anyone? Oh, you are not familiar. So maybe that part will be taken by the Otonu Panda sir or Molloy sir. I don't remember. So here in the discrete Fourier transform, here we found the another type of convolution. That convolution is basically circular convolution. I am not solved over here. When we are studying the circular convolution, that time we discuss. Little bit discuss with the linear convolution also. So two methods are present probably. That is, one is the matrix one is the add multiplication method. This is the add multiplication method, and another method is there. That is the graphical method are there for the linear convolution. In the circular convolution, we have found here a different method are present, that is the computation of the circular convolution by graphical, BFT, IDFT method, matrix multiplication method is there. Then we discuss the linear filtering using DFT. There is a involvement with some application, which is basically overlap save and overlap add method. We also discuss over here, and we also give lot of example, and we do practice lot of exercise over the class. And also in the next class, we also created some your Google Classroom. In this classroom, we also give some assignment which is related with this topic. And the interesting part, I told you that all the part of this discrete Fourier transform associate with the rigorous mathematical solving. That is the reason this part is more scoring part of your subject. More scoring part. If you practice 2-3 times, you can solve it any problem. You can solve any problem. So that is the reason. So I found here today attendance again is down. So next day onwards, you just inform your friends that those people are present in the class. I will take attendance only for them. The exam will conducted only for them, those are present in the class. You just inform your friend, because if you miss any class, you may be suffered. You may be suffered. And I am not taking any extra class. Maybe I'm not, sometimes it's not able to take some class also, because this time in this semester, basically the placement is going on. Those are in the 4th year student, they know very well. This is the basically peak time of the placement. So that is the reason, whenever I take my class, please attend. Otherwise, you have faced problem. Okay. So now, so maybe Molay sir or Otonu sir, they can recommend some books related to this subject. So I am highly recommended these books. This #1 book, that is Digital Signal Processing Principle, Algorithm and the Application. These books are available in your library and also in the market. So we are actually familiar the author. This is Brockis. So I am recommended this book. So a lot of examples are there if we consider the next books, that is the Digital Signal Processing by P. Ramesh Babu. So most of the faculty, they recommended these books, P. Ramesh Babu. This is also available in your library. Now, what about the next 2 parts? That part is depend on the DSP processor. So first one is Xilinx FPGA user manual is an application note. This part are available in internet. You can search it in Google. You get this Xilinx FPGA user manual and application note. Another books we are recommended for the processing part, that is Digital Signal Processing with Field Programmable Gate Array. Maybe this part also available in the internet. So that's all about the syllabus and the basic concept. So we are moving to the next part. Just a second, guys. Now we moving to the next slide. This is also before we start the DFT portion. So we require to know this slide also, this presentation also. So before I start my presentation, I told you one, two things. That is, first one is I already posted in your WhatsApp group the exam code. So please give your exam. Otherwise, you have not get your attendance. So that is the major attendance we are taken. And another attendance I'll take from the Google Meet. Those are present in this meeting link, isn't it? Second part of the story, that is, before I start discrete Fourier transform, you have to know the basic of Fourier transform. Basic of Fourier transform. Okay. So let's start. So here we discuss the advantage of digital over analog signal processing, then application of digital signal processing or processor, different type of signal with their notation, that is very important part. Then we also discuss why frequency domain is preferred, because when we are considering, you know that why we consider Fourier transform. So you know better that we prefer frequency domain, but why we prefer frequency domain? That is the basic thing. So most of the time in the interview, they asking this question. So this whatever are present in the slide, this all of the related with your interview, and also in your Viva question. So here you can see advantage of digital over analog signal processing, analog signal processing. In the figure, you can find that we are considering digital signal processor with this one analog to digital converter, D to A converter, and associate circuit we are considering as an analog input. Then that part is after conversion, that part is basically digital input. Then after the processing, we get also a digital output. And after D to A conversion, we get the analog output. So you already familiar with this block diagram. Now the advantage of digital over analog signal processing. A digital programmable system allow, so it's not only the digital system, this is, we are recommended that digital programmable system. So anyone have any idea about programmable device? This response, anyone have any idea about the programmable device? Have you heard anyone programmable device? Give some example. No. Programmable device. I mean to say, I'm not talking about the microprocessor or microcontroller. I'm talking about the programmable device. Have you heard the programmable device? Can you give some example? Syasys, can you give some example of programmable device? No. Syasys, just a second. So you are already learned the digital electronic subject, yes or no? So in the digital electronic subject, there is a part programmable device. Have you heard? Okay, have you heard PLD? PLD, have you heard PLD? Have you heard from PAL, PLA? Have you heard, guys? Anyone? You heard this? So this is basically your programmable device. What is that? Anyone please tell me? What is? What about their structure? What about the internal structure? Remember? Okay, you are right. You are right. You are right. So anyone recall that what the architecture of PAL or PLA? Anyone? Anyone please respond. Anyone please respond. ওরে কেউ তো কিছু কথা বলে, এতজন কি জন্য বসে রয়েছিস ক্লাসের মধ্যে? ফ্রম নেক্সট উইক অনওয়ার্ডস যদি ফিজিক্যাল ক্লাস হয় তখন তো বকতেই হবে। প্লিজ টেল মি এনিওয়ান ইফ ইউ রিমেম্বার প্লিজ। ভেতরে কি কি জিনিস থাকে? ওকে, I just tell you one thing. Decoder design. Do you remember the decoder design? You using decoder, you make some full adder. Using decoder, you make some circuitry. You remember, guys? So, what about the internal structure of the decoder? What about the internal structure of the decoder? Which gate? Which gate? And yes, and not gate. And not gate. This is for the decoder. And if we design using decoder, what gate we are actually found in the end part? No. So if we consider, if we make a circuit using decoder, suppose this is my decoder. Okay, this is your input, suppose for example. What about these block are present where we get actually output part? So decoder, you know, the 8 line is there. So this is on some combination here. We found the output. So this is the input. Anyone? Yes. So this decoder making using and not gate. And what about this part? So you remember, whenever you design something using decoder, you are using OR gate, yes or no? Tell me, guys. I want some other response, please. Whenever you design using decoder, that time you are using OR gate also. Yes or no? So this is the basic. If both part are fixed, that time we call this is ROM. This is ROM. So how the make ROM? What about the architecture of ROM? ROM is basically making using and OR array, and OR array, isn't it? So now the difference between ROM and PROM, So PROM means P means the programmable. Whether that OR part is programmable means we can reprogram this OR part, not in the AND part. So this part is basically totally you will learn in the digital electronics when you are studying on digital electronics. So I request you guys, please see any books. I am recommended any books in the digital. You just see and please try to understand about the programmable device. So here we write a digital programmable system that will actually come from that PLD. So if you don't have the proper knowledge of PLD, that can be difficult to understand about this digital programmable system. So digital programmable system means there is a circuit. Okay, now we are coming to the processor. There is a circuit. So some part. So suppose this part is fixed. And this part is programmable. Programmable means this whole part we are considering as a processor. In the processor, some part are fixed and another part is programmable. That programmable part making using this programmable logic device, isn't it? So if this part is programmable, we can change the logic according my requirement. Yes or no? If this part is programmable, that means according my requirement, we can change the logic. Yes or no? Are you agree with me? Yes or no? Yes. So that's why I am written here, a digital programmable systems allows flexibility in reconfiguring the digital system signal processing operation simply by changing the program. So usually we understand program means, sir, I know Python, I know, sir, Java, I know C. No, I am not talking about that program. This is different type of program we are considering here. That kind of program is basically change the hardware logic. I am not talking about the software programming part. I am talking about the hardware programming part. Usually we call this is HDL. Are you familiar with this term, HDL? What is that? Hardware description language. So a lot of language are there. VHDL is there, Verilog is there, JHDL, Java-based HDL is there. But this is hardware description language. This is hardware language. We are talking about the hardware language. So changing the program means using hardware language, we change the logic. Clear? The first point you understand, guys? Anyone having any doubt, please respond. Because this is the new thing. I told you the new thing, so that's why I am asking several times. If you have any doubt, you please tell me. So after my class, not now, after the college session is over, you must learn in the internet, or you can see any book. I am recommend any book related with digital electronics. You just learn basic of PLD, programmable logic device. This is the foremost job for today. I'm requesting you guys, this is very interesting. If you have any problem with this programmable logic device, I will show you one day for the programmable logic device. Now yeah. FPGA, HGBA is not the name. Name is basically I am written over here. That is FPGA. Are you talking about the FPGA? Yes. This is also one kind of programmable logic device. In educational sector, in the industry sector, we are actually using this FPGA. The PLD means we are considering three major PLD, that is from PAL, PLA. The logic, whatever you are applied in this PAL, PLA is from is small type of circuit we are actually implemented. When we are considering FPGA, we are given logic size is more bigger compared to PAL or PL. Another have you heard this? Another circuit is there. Just told you. That is, you are familiar now. You are just known this term. That is PLD. Have you heard CPLD? Have you heard? This is nothing but the PLD. This is also a PLD, but it's little bit complex. So that's why we call this is CPLD. So more or less same category we found in CPLD and FPGA. This is absolutely different topic, but this is very interesting. This is very interesting. Later on, if we require, you please tell me. I will take one class for this part only, the programmable part. This is very interesting. Now we are talking about the digital signal processing. So we are now moving to the topic. So now you are familiar, you are now understand the first point. A digital programmable system allows flexibility in reconfiguring the digital signal processing operation simply by changing the program. Now, what about the next point we are considering? Codes are often used in the transmission of information. Those codes can be used either and mean of keeping the information secret or breaking the information into a small pieces, and which is basically manageable by the technological use. This is very vital point why we are actually using the digital over analog signal processing. This is very vital point why we are actually using digital over the analog signal processing. We can secrete the information basis on the transmission process. And we can make a small pieces for manageable by the technological uses. So what about the next point we are considering? Just a second, guys. Yes. I told you one thing, that is in the microprocessor, two types of microprocessor are there in the market. Okay. What is that? One is the general purpose microprocessor we call, isn't it? General purpose. General purpose means we can feed this, we can feed this processor in anywhere. Your computer having a processor, yes or no? That processor is general purpose. But the processor are present in your mobile phone also, guys, yes or no? So mobile phone, any appliances like your air conditioner, washing machine, whatever, also present a microprocessor, also present a processor, isn't it? But that processor is not bigger size, because this is more application specific. Suppose, for example, whatever processor present in your computer, maybe that is 64 bit, maybe that is 64 bit. So they can deal with 8 bit, they can deal with a 4 bit, 16 bit, 32 bit or 64 bit. So that's why in general we are using, in the general purpose processor, we are using either 32 bit or 64 bit processor. But in case of your washing machine, fully automated washing machine, so that washing machine having some application, are you agree with me? So for this particular application, we don't require the 64 bit processor, yes or no? So that is the reason we come with some special type of processor. That special type of processor, one part is common. Which part? Like your timing control unit, like your sometimes ALU part is common, some register part is common, isn't it? Instruction register is common. So common part is there. With this, some accessory, some other part is also present in the processor block, which is programmable. Suppose, for example, when we are considering digital signal processing, that time rigorous work with addition and multiplication process, yes or no? So for that purpose, we build some logic over this processor unit using the programmable part, isn't it? Is that clear? So this is very interesting. If we talk about that part, okay, we have another class, that is the I am taken the computer architecture. That time I also discuss about this all detail part. If you are interested, isn't it? So unfortunately, time is over. This is 10:20. So thank you for attending my class. So I request you guys, please look on the topic, whatever we discuss, that is the PLD part. I just recommended any books. Please, you can get the topic PLD in internet also. You just give 1 hour for this topic, isn't it? So thank you for attending my class.